We'll discuss commands. In computing, a command is a directive to a computer program to perform a specific task. It may be issued via a command line interface like shell, or it may be issued as an event in a graphical user interface triggered by the user selecting an option in a menu. And we can execute two types of commands from inside a shell script. There are normal commands that you could also execute from the command prompt, which is called external commands. And there are built-in commands which are called internal commands. The built-in commands are implemented internally to the shell and can't be invoked as external programs. It generally doesn't matter if the command is internal or external, except that the internal commands execute more efficiently. Here I will cover only the main commands, both internal and external, that we will use when we are programming the scripts. The first one is break command. We can use break for escaping from an enclosing for loop, or while loop, or until loop before controlling condition has been met. We can give break an additional numeric parameter, which is the number of loops to break out of, but this can make scripts very hard to read. By default, the break escapes a single level. Now we'll see an example of break command. In this example, I'm using break command in the if condition in the for loop. The if condition I have specified here contains a file conditional called -d to check whether the given file is a directory or not. The if condition will return true if the value that is provided as a parameter for the file conditional is a directory, and it will enter into the block and it will execute the break command. I will show you the output in the terminal. Break.sh. So this is the code. Now when I execute it, it shows first directory starting Fred was Fred 3. So when we look into the code here, the first two line represents Fred 1 and Fred 2 was created, and the third line mkdir command is used to create Fred 3. There is a directory, and Fred 4 is a file which was created here with the help of this line. Means I have Fred 1, Fred 2, and Fred 4. These are the files, and Fred 3 is a directory. When I'm iterating the loop, the file variable contains Fred 1, where Fred star is the wildcard expansion, and Fred 1 is provided here as an input. And if -d dollar file, that means here Fred 1 is provided as an input here. If the condition is satisfied, then it will execute break command. But here Fred 1 is not a directory, it is a file, so it doesn't execute the break command. Now the loop will be iterated once again, and Fred 2 will be taken into consideration, and it is a file, so it is not a directory. Again the loop will be iterated, and now Fred 3 is a directory, so the loop will be iterated. So it shows that Fred 3 is a directory because it is specifying as Fred 3 is a directory. So it shows the output because it executes the break command. And echo first directory starting Fred was file. By looking into this code, the first two lines create a file, the third line create a directory, the fourth line create a file. And these values, Fred 1, Fred 2, Fred 3, and Fred 4, are replaced with Fred star, where Fred star is a wildcard expansion which is given as value for the variable file. When I'm accessing file in the if condition like $file, it has to take the value Fred 1 for the first iteration, and it has to compare whether it is a file or directory. As I am specifying the file conditional -d, I need to look for whether the Fred 1 is a directory or not. Here Fred 1 is a file, so which is not a directory. So the if condition is not satisfied. The loop will be repeated once again, where it will take thread 2 and it will compare. So it is not a directory. Again, the loop will be incremented and the thread 3 is taken into consideration. Now the if condition is satisfied because thread 3 is a directory. So it will enter into the if condition and it will execute break command. Once the break command is executed, it will comes out from the loop and it will execute. First directory starting thread was thread 3. After that, it removes all the files which are available with the name thread. That means it is going to remove thread 1, thread 2, thread 3 and thread 4. So now when I execute find command to look for thread 3 because the if condition is satisfied and it is a directory, it shows that the break command is executed and it shows that the file thread 3 is available and the first directory starting thread was thread 3 was printed. So when I look for find thread 3, as I am implementing rm command in the program, the thread 3 is also removed. So it shows no such file or directory. Now I'll discuss about the colon command, which is a null command, which is occasionally useful to simplify the logic of conditions, being as an alias for true. And we may see it used as a condition for while loop, like the while colon implements an infinite loop in place of the more common while space true statement. And when we look into the code, I'm removing the file called thread and I'm checking the condition thread whether it is a regular file or not. If it is so, then it will execute the colon command and it will simply comes out from the code. If there is any statement after the if condition, it will execute the statement, otherwise it will comes out from the code. Here I am writing else block. If the if condition is not satisfied, the else block will be executed. After closing the if condition, that means after the fi command, if I write any statement to be executed, and if the true condition is returned by the if statement, then it will execute the colon command, which in turn consider it as a true and it will comes out from the if and it will execute the statement that was written after fi command. Now I will show you in the terminal. So this is the code. I'm commenting rm space hyphen f space thread. And I want to know whether the thread is available or not. The file name thread is available or not. So I will check once again whether there is any file with thread or not. I don't have any file with a thread start. Okay, I will look for thread because we need thread. So it is also not available. I will create a file with thread, some content. Now I'm going to execute the file colon.sh. So it shows nothing because when we look into the code, the condition if is satisfied because the file is not removed because rm command is commented here. So the if condition is satisfied because f hyphen f space thread means the thread file is regular file and it is available. So the true condition is satisfied. So it will enter into the if condition and it will execute the colon and it comes out from the code. And I don't have any statement after fi command. So it simply comes out from the code. And I will modify the code. I will add a statement at the end of the if condition outside of if condition. And when I execute it, it shows outside of if condition because the file thread is not removed. Just I have added a statement at the end of the fi condition. So it shows the statement that was executed which contains the string outside of if condition. When I uncomment the line and when I execute it, it shows file thread did not exist. And after that, the else block is executed because I have removed the file with the help of rm command where I uncommented the first line. So thread file was removed as I uncommented this line and the else block will be executed which contains a string in echo command as file fred did not exist. And after fi command, I have a statement that is executed, which is outside of if condition.
Continue. Rather like the C statement of the same name, that is continue, this continue command makes the enclosing for loop or while loop or until loop to continue at the next iteration, with the loop variable taking the next value in the list. So now I will show you an example regarding the continue statement, the same program. So now I will execute the same program in the terminal. So I have one more example here. Before the executing this program, I will write another program that I have shown on the screen. So that is a rm command I have implemented. Then the same program that I have executed for the break command, I'm going to write it here. So before that, I will copy the break program with another name. Copy. Continue example.sh. So now I will open continue example. Instead of the break statement here, I will write continue. So I'm changing the code. Echo directory exist, because I am checking for whether it is a directory or not. So the directory exist, and instead of the continue break, I am writing continue here. Then I am closing the loop statement. So I will execute the program here. So the directory exists, and the first directory starting Fred was now it is Fred 4, because I'm not using break statement, I'm using continue, so it will continue with next iteration, and the dollar file value is now replaced with Fred 4. So as I specified the statement first directory, it is a string, so it shows the same as output here. So instead I can change the statement here. I will simply display the file name. Instead of writing a first directory Fred was, I'm removing this string here. I will simply display the file name. Now I will execute the program. When I execute it, it shows directory exist and Fred 4, it is a file name. So that is an example of continue statement or continue command. When I execute ls Fred star, it shows no such file or directory, which was the same that I have discussed with you regarding the break statement, where I have rm command at the beginning and rm command at the end. In between these two lines, I have some commands which I need to create: Fred 1, Fred 2, Fred 3, and Fred 4. Here, Fred 3 is a directory, so it prints directory exist when the condition is satisfied with Fred 3. But for Fred 1 and Fred 2, the condition is not satisfied, so it will not execute the if condition, and the loop will be iterated to next iteration, and it will look for Fred 2 and it will look for Fred 3. Now Fred 3 is a directory, so it specifies directory exist, and the next iteration is Fred 4, that is a dollar file is now containing the value Fred 4, and there is no next iteration after Fred 4, so it will comes out from the loop, and dollar file will now contains with Fred 4, at that value will be displayed here. After that, I have executed the rm command to remove recursively and forcefully all the files which are beginning with Fred. Continue can take the enclosing loop number at which to resume as an optional parameter, so that we can partially jump out of the nested loops. If I have nested loops, then it will be helpful to jump out from the nested loop by using the optional parameter to be specified with continue that I am showing in the example, that is a continue 1. So now I will show the output of this program in the terminal. That is a code. Here I am writing the code. So I am saving the program. Now executing it. So it shows before 1, before 2, and before 3. If I remove continue 1 here, if I comment this line, we will get the output like this: before 1, after 1, before 2, after 2, likewise. The dot command executes the command in the current shell. The dot command executes the command in the current shell. Example, dot space dot slash shell script. Earlier we have executed dot slash a dot out. Dot slash a dot out represents the file a dot out is available in the current directory, that is dot. Now I want to execute the command in the current shell. So for that I need to specify dot followed by space followed by dot slash a dot out. Like I am showing in the screen, dot space dot slash shell underscore script. I can give an example regarding this. Dot space dot slash a dot out, so that it will execute the command in the current shell. Current shell in the sense we have two different shell prompts like dollar and greater than sign. And I will show an example here. One is the classic set which contains the code version is equals to classic, path is equals to slash user slash local slash old underscore bin colon slash user slash bin colon slash bin colon dot. That is a path that I have specified here. And the path is changed with classic greater than. Instead of dollar sign, PS1 represents prompt sign 1. That is a dollar sign that we have, and that is changed with or initialized with classic greater than. Now the prompt is changed from dollar sign to classic greater than. Now I'll execute the same in the terminal. I will give the file name as classic underscore set dot sh. Version equals to, I am specifying classic as a value for the variable version, and path is an environment variable. I am specifying the path slash user slash local slash bin slash world underscore bin slash, before that colon is a separator, that is a, this entire thing is one path, that is a slash user slash local slash world underscore bin is one path separated by a delimiter colon, then slash user slash bin colon /bin colon dot. Then I'm specifying the prompt symbol, that is a prompt string. PS1 means prompt string 1 is equals to classic greater than. So that is a prompt string that I want to change now. When I execute this program, so it doesn't change the prompt sign now. So I will make the script executable by using chmod command plus x classic set.sh. Now dot slash classic set.sh, it doesn't change, but I need to execute it with dot command so that the prompt will be changed. When I execute it with dot slash some file name .sh, it will not change. That means the command is not executed in the current shell. It may be executed in another shell. So I want to execute the command in the current shell. So I am using dot space dot slash classic underscore set.sh. Now the prompt is changed. That is classic greater than. Now if I want to execute echo command, I can execute some echo command here, or I can also display ls, or I can apply clear command, I can execute date command. Everything is same, which I was executed with dollar as a prompt. Now the prompt is just changed to classic. So normally when the script executes an external command or a script, a new environment is created. When a script executes an external command or a script, a new environment is created. That is called a subshell is created. The command is executed in the new environment, and the environment is discarded apart from the exit code that is returned to the parent shell. However, the external source and the dot command, either external source or it may be a dot command, both are one and the same. Run the commands listed in the script in the same shell that called the script. The dot command is going to execute the commands that are listed in the script in the same shell. Because when I'm executing the command in the terminal, here the command in the sense I am specifying the shell script name, which I have specified execute permission with chmod command, and I'm executing that particular command now. So when I specify execute permission for the shell script file will becomes a command name now. Now when I'm executing the command, it in turn executes some other commands that are available in the script. So when I run the commands listed in the script, it has to execute those commands in the same shell that called the script. So if I want to do that, then I have to use dot command. Because by default a new environment is created, a shell script is executed, any changes to environment variables that the script makes are lost. If there is any change in the environment variables that the script is going to do, those changes will be not available, because a new environment is created when the script is executed. And the dot command on the other hand allows the executed script to change the current environment. So this is often useful when we want to use a script as a wrapper to set up the environment for the later execution of some other command. For example, when you are working on several different projects at the same time, so you may find you need to invoke some commands with different parameters. Perhaps to invoke a older version of the compiler for maintaining a older program. And in shell scripts, the dot command works a little like hash include directive in case of C or C++. So though it is literally doesn't include the script, it does execute the command in the current context. So we can use it in incorporate variable and function definitions into the script. So now by looking into the another example, other than classic underscore set, I can specify one more example with latest underscore set, which contains the same lines of code. The scripts are executed using the dot command. So each script is executed in the current shell, and this enables the script to change the environment settings in the current shell, which remains changed even when the script finishes executing. So now in the terminal, even the script is executed successfully, even if the script is terminated, the prompt doesn't change it here. The prompt remains same. That means it enables the script to change the environment. The environment is changed, but the current shell, which remains changed even when the script finishes executing. So now I will open one more terminal to show the prompt sign. So now the prompt sign is $. So when I execute the latest underscore set, I think I already written the program here. So now I will execute the same program. So I have specified some space here. I will remove the space. Okay, this is a prompt sign that I want to change now. So now I will execute this by using dot space dot slash latest. So this is the prompt sign, which remains the same even after the script terminates its execution. So now I can execute any command in this terminal. So that is the use of dot command. With the help of dot command, I can execute the commands in the current shell.